In this video, we're going to run through a lot of examples on identifying the level of measurement and whether or not the variable is discrete, meaning the variable or the values can only take on a set number of possible options, or continuous, and a variable or the values of a variable can take on really any value, at least within a certain range. The first variable that we're going to look at is year. So year and temperature is a classic example of an interval level variable. We have real numbers, and so that means it is either interval or ratio. We have different calendars, so from that we could assume that there is no mandatory 0 point. There's nothing inherently special about a year 0. So we could, in theory, add 100 or subtract 2,000 from all of these and reset our years to 0. And the world doesn't break. Nothing super bad happens. So that combination of being able to move the 0 point around, as well as having actual numbers, puts us in the interval level of data. Time is continuous, so we could subdivide units of time to an infinite and arbitrary precision. So take a stopwatch and add as many decimal points in that stopwatch time as the stopwatch will give us. So time is continuous. Year, however, at least in this particular data set, it is discrete. So we only have whole numbers of years. The data set will not allow us to have every possible year from 1998 to 2018. We cannot, for instance, have 1998.2. That is not allowed. And since there are values that are not allowed, this has to be discrete. Number of salmon, that is an example of a count. All counts are ratio level. We can't have a negative number of counts. That 0 point is not something we can arbitrarily move. There's a physical meaning to it. So it is ratio level. It is also discrete. We don't allow portions of counts. Now, number of salmon, we can see there are lots of different options, more than we have just in years. But having lots of options does not differentiate whether or not something is continuous or discrete. We do not allow, again, fractions of things, and it is that which defines counts to be discrete. So all counts, such as number of salmon here, again, are ratio level, true numbers with a fixed 0 point, and discrete. In the archaeological ice patch data, we have a Borden number. I'll admit I don't know what a Borden number is, but fortunately it doesn't seem like we're going to have to know what that is. These are not real numbers, so we're not at the interval or ratio level data. We're either nominal or ordinal. And at least by looking at this, I cannot identify any pattern that would suggest the Borden number has an inherent ranking to it. So I will go on the assumption that the data are nominal. That is, they are categories, but no inherent ordering. All categorical data are also discrete. So we are limited to the number of categories, not necessarily limited to the number of categories in the data, but there are only a fixed number of categories, even if some of them don't appear in the data set. So nominal and ordinal, because those are based on categorical data, both of those must always be discrete. We can see that put in practice here. Ice patch name. This ends up being the same thing as the Borden number. We don't have numbers, so it's either nominal or ordinal. There's no inherent way of ranking these data. So we have Jojo 8 above Granger. We could just as easily have Granger above Jojo 8. It doesn't particularly matter which way these were arranged. Because it does not matter, they are not ordinal, so it is nominal, unordered categories. Again, all categorical data are discrete. We are limited to the categories represented by the names of the ice patches. And again, it also does not matter whether or not all of the categories possible are represented in the data, as they're still categorical and hence still discrete. Elevation can be a little bit tricky. So elevation is a physical measurement. We have a real number. So in the problem set that I gave you, elevation was actually a category. I gave you a range of data, and even though there were numbers in those ranges, you could make a valid substitution saying like a low range and a low to medium range and that kind of thing, which would make it a category, and specifically an ordered category. So that would have been ordinal level data. Again, that was for the problem set. This data set, we do not have categories. So these are the actual elevation measurements. These are the raw numbers. So we're either interval or ratio level data. There was a previous video that gave an example about elevation. And that example would suggest, and I think correctly, that elevation is actually an interval level data. We have to specify what our 0 point is. It's generally something like meters above sea level, but we're not stuck with that. We could have meters above my house, meters above the Yukon River, meters above the center of the Earth. We can shift that 0 point around. And because we have a real number and we can shift the 0 point, I would argue that elevation is an interval level data. Now, I would also accept elevation as a ratio level data if you made the case that there is, for instance, an accepted standard that 0 is meters above sea level. Or if we're talking about meters above the center of the Earth, well, we can't have negative values. That 0 does have a very physical meaning. So, I could go either way. Just as long as you realize, as the previous video suggested, as long as you're realizing what the implications are of that 0 point. Elevation as a physical measurement of distance, distance like time, technically is continuous. We could measure that to an arbitrary precision. In the data set, we do not have the ability to measure it to an arbitrary precision. We have it measured down to the nearest meter. There's some rounding going on. So the data set has elevation as a discrete variable. Again, lots of possible values, but not all possible values, at least within a certain range. So elevation here would be discrete. It's a little bit easier in the size category. So we have small, medium, large, no numbers, but there is a distinct order. Small is always going to be on the opposite side of the data set as large, at least as far as the rankings go. So an ordered, or a set of ordered categories makes this an ordinal level data set. And because we have categories, it must be discrete. Number of artifacts, this is kind of like salmon. It is a count. So for the same reasons as before, count must be ratio level. It has a valid 0 point that can't be moved, and discrete. Year we already talked about. Year is our classic interval, and it is also discrete in this particular data set. The dental hygiene data set, we have, again, ordered categories, so that makes it ordinal level, and discrete, because categories are always discrete. And here is a count, and just like the fish, counts must be ratio level, there's a true 0 point, and discrete, we don't have partial numbers of people. Percentages are a little weird, so it is a true number, so we would assign that to either the interval or ratio level category. There are decimal points, so that may or may not be, really that doesn't help us differentiate between interval and ratio. We may be tempted to say that it is ratio because a 0% means nothing. That is there's a fixed reference point there, and I would agree with that. So percentage should be ratio level. The other question would be whether or not percentages are continuous or discrete. So we have decimal points, and that may be our indication that percentages should be continuous, because we could have more and more decimal points as we wanted. In fact, Excel will happily add more decimal points to us, or to this. However, it's important to realize for percentages that this percent came from this n, and that means we can't have every possible number, even though we have some decimals here, we can add as many more decimal points as we want. Every possible number is not available. We can, in this very low category, for instance, we could have 0 out of 114, or 1 out of 114, 2 out of 114, but we can't have 1.1 out of 114. That possible percentage is not available to us. I realize perhaps that's not the greatest example. It's 114 out of the total. So let's actually do it that way. The sum is 712. So there was a possibility of 0 out of 712, 1 out of 712, 2 out of 712, but not 1.1 out of 712. That percentage is not available in our data set, and it never will be. So even though we have decimal points, and the n could change to whatever it wanted to be, at least in any particular category, these percentages are actually still discrete. Perhaps an easier way to think about that is the percentages are based on the count. So whatever data type the count is has to match the percentage. So count we know is a ratio level discrete variable, and so percents, which are based on count, also have to be ratio level and discrete. So ratio and discrete, ratio and discrete. The P for trend, this also has to be ratio and discrete. Well, that's harder. I'm not sure if that P is a statistical test. So, let's just skip that for now. I'd have to think about what that one is. It certainly won't show up in the test. Here we have different types of cancers. So these are non-ordered categories. We can't, there's no inherent order in them, so they will be nominal level. Males and females are nominal, and because both of these deal with categories, they will also be discrete. Here we have counts, and counts must be ratio and discrete. And lastly, the earthquake dataset that we've seen quite recently. Year, we've already come across a few times. Years are interval, and in this dataset, again, interval and discrete. Latitude and longitude. So this is another potentially tricky one. So it's a physical measurement. We have decimals. We could have lots of decimals. In effect, it's a distance, and so we can measure this to an arbitrary precision and get any possible number we wanted to between a range. One might be tempted to think, well, even before going there, so we're talking about real numbers, so it's either interval or ratio. And so the question is whether or not it's okay for us to move the 0 point. Now, if we think about what latitude and longitude means, and maybe longitude, well, either of these, geographers have gone and defined a place on the world that we'll call 0 latitude, the equator, and 0 longitude, the prime meridian. Those specifications are, somewhat arbitrary. We could have had a 0 latitude at the North Pole and have it increase to 180, for instance. The longitude, the prime meridian doesn't necessarily have to go through Greenwich. It could go through Whitehorse instead. So we could move kind of the 0 place around. But that's not really the same thing as moving the 0. So latitude and longitudes are effectively angles, especially latitudes. We're talking about drawing a line from the middle of the Earth and how high, how big the angle is from the equator up to the point of reference. Because it is an angle, this geometric measurement, there is a true 0 point, and it doesn't matter if our point of measurement is relative to the equator or the North Pole. As long as we're still defining latitude geometrically, there's still a valid 0 that we can't just arbitrarily add or subtract numbers to. So latitude, at least, is ratio level, even though we had the option of defining the equator versus some other place. Magnitude, that there is a fixed 0, no earthquake at all, and we have no choice in the matter, so that is a ratio level variable. We could also, in theory, measure this to whatever precision we wanted. So this is a ratio and continuous, a latitude, and also longitude, ratio and continuous. Region is non-ordered categories. So that one is hopefully at this point pretty easy. It is a nominal level variable. And because it's categories, it must also be discrete.